All right, so the next section is going to be adding and subtracting rational expressions. In order to add and subtract fractions, you have to have a common denominator. So before we get to the adding and subtracting, I want to talk about how to find the common denominator. We've got two types of problems, monomials and polynomials. We'll start with the monomials. To find the least common denominator, you're going to find the smallest multiple of all the coefficients. Now, we're not looking for GCF. We're looking for a number that they can all divide into. It will be at least as big as the bigger coefficient. It's probably going to be even bigger than that, but we want that they all divide into. All right. Then, if there's any variables in anywhere, you're going to include all the variables with the largest exponent. So it's different than GCF. Let's look at this first problem. Now, my coefficients are 9 and 6. I need a number that they both can divide into. They both can divide into 18, so my LCD between the 9 and the 6 will be 18. Now they both have x's, so my LCD is going to have x, and it's going to have x with the largest exponent. Look at the second one. I've got a 15 and a 3. So we're going to look to see if we can find a common multiple between 3 and 15. Here's what I recommend. Take the smallest one and see if you can divide it into the bigger one. We can divide 15 by 3. So because 3 goes into 15, 15 is the common multiple. Now, since they both have x's, my LCD will include an x and the largest exponent. Look at these three. We've got an 18, a 3, and a 6. I want to find something that they can all divide into. Now, I always check the smallest ones to see if they can go into the bigger one. Well, 3 goes into 18, and 6 goes into 18. So that means 18 is the common denominator. Now, I see x's, and the largest exponent is 4. So the common denominator between those three monomials is 18x to the 4th. Now look at this one. There's a 4 and a 7. The common multiple between 4 and 7 is 28. Now notice one of these has an x and one of these has a y. My LCD has to have both the x and the y. If I had 15 different variables, my LCD is going to have 15 different variables. And they're going to be the ones with the largest exponents. So look back over these examples and watch it again if you need to. Now, for polynomials, it's a little bit different. For polynomials, we're going to have to factor. So far, in order to do any of this stuff we've done, we've had to factor. We're still factoring stuff. So the first thing we're going to do is factor. All right, so let's factor this first one. It's got a GCF, and we factor out a 1. I mean, x. This one is x plus 1, x plus 2. I guess over here, I'm going to find the LCD. Oh, come on. I want to show you what we're talking about. Everything's factored. Now, step 2 says to include everything from the first one we factored. Now, first thing I did was factored I got an x and an x plus 1. My LCD will have an x and an x plus 1. What number 3 means, I look at the second one that I factored. If there is something that these two pieces are not sharing, I've got to put that as part of the LCD. Notice, let me just show you, let me use the highlighter here. Notice both of them have an x plus 1. They are sharing the x plus 1. So, since they are not sharing the x plus 2, we have to include the x plus 2. If they're sharing it, we don't include it. It's already there. So for this problem, the LCD is made up of an x plus 1, and an x plus 2. It's all about the factoring. All right, let's do it. Now this one's already been factored for us. So I want to find the LCD. I'm going to use blue this time. Okay, now whatever's in the first one must be included. I've got to put an x and an x minus 6. I don't care what this is. Whatever's here is going to go here. I don't care if it was 15 different binomials. You're going to put 15 different binomials in your LCD. I can't stress that enough. Now, I come to the second one and I look to see if there's anything they're not sharing. I'm going to highlight the piece that they're sharing. What I don't have highlighted is also in the LCD. So my LCD will contain the 2 and the x plus 1. So the LCD for these two polynomials is a 2x, x minus 6, and an x plus 1. Look at the next one. Now these have not been factored, so we've got to go factor these out. This one has a GCF. This one is x minus 3, x minus 3. Okay, so whatever is here, this all will be part of the LCD. We're going to have a 3 and an x minus 3. The second one, we're going to include anything that it's not already sharing. Again, I'm going to highlight the shared piece. Now notice the second one had 2 x minus 3s. Well, they're only sharing 1 x minus 3. But because there's 2, we have to include the second one. My LCD has to be a combination of both things. Whatever's in the first one and some of the stuff from the second one. This gets a little tricky when you got the same binomial twice. So the rule is, if you got the same binomial twice in the same piece you factored, you include it twice. If I had x minus 3 3 times, I would include it 3 times. But just pay attention. To get you a highlighter and highlight the ones that match, and if you don't have, and whatever's not highlighted, put it with the LCD. Alright, let's do this one. X minus 3, x plus 1, x plus 4, x plus 1. Alright, so the LCD will be, have to include the x minus 3 and the x plus 1. Then it will include anything they're not sharing. So I'm going to highlight the shared piece. Since they're not sharing the x plus 4, we have to include the x plus 4. Now, I want to actually do, well, I'll do the other stuff in the next lecture. I'm going to stop here.